When I was a child, my father took me to Isfahan, a city in the center of Iran that was once the capital of the Persian Empire and is known for its grand boulevards, magnificent palaces, and historical monuments. We walked through a narrow street that led to an old, decrepit building built in the 17th century that had the name Garmabe Sheikh Bahai inscribed above its door. It was a bathhouse named after its architect, Sheikh Bahai. He told me what was special about the building was that the water of the entire bathhouse used to be heated by a single, ever-burning candle. And no one knew how it worked. And apparently, the candle was burning for a long time until a group of people, trying to solve the mystery, demolished a part of the building to access the furnace. The candle went out, and they were never able to turn it back on. I was so mesmerized by that story, and for months, I couldn't stop thinking about the single candle somehow defying all the laws of physics and heating an entire bathhouse. It was like architecture producing a kind of magic. And it was, in fact, during that time, when I decided that I wanted to be an architect. I came to understand architecture as a field that combines art and science to create innovations and meaningful and often mysterious connections between bodies and the environment. Years later, I started my own practice with my partner, Marta Novak, based on the same conviction. And we began working with individuals and companies that shared our vision in innovation. As a design partner of Hyperloop Transportation Technologies, for example, we had to envision a completely new way of travel and passenger experience. We also collaborated with UCLA City Lab on a project for NASA Jet Propulsion Laboratory, where we were asked to redesign JPL's offices in Pasadena, California. But when we visited JPL's offices, we found ourselves in a very familiar environment. A dull, generic space filled with desks and cubicles, not unlike many offices you've probably experienced. And it seems like no matter who we are and what we do, we all use the same old desks and those stubborn chairs with tiny, squeaky wheels. So we realized before we could really reimagine the office environment, we needed to rethink and redesign the office furniture. For us, furniture is architecture at a human scale. So we took inspiration from JPL's rovers, Spirit, Opportunity, and Curiosity, and designed our own office rover, which we called Productivity, which is an individual pod that can move around the office on its own. It provides privacy, but can also plug into a desk for meeting or collaboration. But most importantly, since Productivity has rover wheels, it can maneuver any terrain. And that enabled us to completely transform the interior environment. Why not? But these ideas don't have to be limited to the use of advanced technology. We also designed them a chair that could be easily moved and reconfigured. It is inspired by a few of our favorite modern chairs, which we basically placed around the circular frame. So not only you get to use the original chairs, but also infinite number of seating possibilities in between them. We call it zero gravity because it only stabilizes with the weight of a person inside. There is a direct physical dependency between the body and the piece, where the two balance and complete each other. Now, throughout all these projects, I had been thinking about that mysterious bathhouse. And a few years ago, I came across an article that claimed to have finally solved the mystery. It described that recent renovations have revealed that the boiler was made of gold, a great conductive material, which explains the bathhouse's efficient heating system. But it also described a network of ceramic pipes that connect the furnace all the way to the sewage. This meant that the candle had a constant supply of biogases, like methanes and sulfur oxide, that could keep it burning forever. So when the candle mysteriously went out, it was because the bathhouse had to be closed for repair, therefore no one was using the toilets, and hence no fuel. This new revelation not only solved the bathhouse mystery, but made it a lot more interesting to me. Now, the use of biogas as fuel was not unprecedented, but what made the building especially unique was that it placed those engineering innovations in a direct dialogue with human bodies and their use of space. Suddenly, the building's mechanical systems and the body's metabolic system merged and became one, a self-sufficient, closed system. And yet, it wasn't just a direct interaction between the body and the building. The architecture also produced interesting, even if absurd, connections between various individuals within the building. One person's waste became the fuel for another's warm bath. This interest in building technology and the relationship between the body and the building also led me to the study of hospitals. In the 19th century, for example, because of disease theories and focus on ventilation, hospital buildings were seen as therapeutic machines. And in fact, most were designed by doctors rather than architects. The Johns Hopkins Hospital in Baltimore is an interesting case. The project was led by a doctor named John Shaw Billings, who, unlike an architect, approached it as a technical, scientific problem. Billings did extensive research, and he even tried to test his ideas through a series of experiments. But he wasn't able to emulate the real-life conditions of a hospital ward in a laboratory environment. So instead, he decided to build a hospital ground up with the intention of using it as a full-scale architectural experiment, what he called a laboratory for heating and ventilation. So each building had a different form and layout, and with a unique heating and ventilation system. He also included many interesting architectural details, like rounded corners to facilitate airflow and cleaning, self-closing doors to control air circulation, even perforated floors and ventilated ceilings so that no particle or germ from one person would ever reach another. And once the hospital became operational, Billings was able to correlate the environmental performance of his systems with the condition of the patients in each ward, and therefore arrive at the best architectural solution, what he considered a perfect system of ventilation. But to me, what Billings' experiments also reveal is the limitations of conventional representations of buildings that often assume architecture to be a fixed, solid container. This is why in my teaching and with my students, we study and analyze the movement and behavior of gases, fluids, particles, and also people that inhabit our buildings. And this is something that we also took into account in the design of a medical office building that was recently completed, where we were asked to focus specifically on the problem of human circulation. Now, the movement and interaction between doctors and nurses, patients and staff in a medical office is a highly complex routine that runs like clockwork. And what we learned is that we can neither rely on our naive assumptions about how people move and behave, nor do we have the means to test those in a laboratory environment or a full-scale experiment, like in the Johns Hopkins Hospital. So taking advantage of recent advances in simulation technology, we use software that can simulate the movement of people in a digital environment. We set up a computer model and ran the simulations multiple times. And each time, the result showing us traffic in congestion areas would allow us to go back and make necessary adjustments, like widening a door or a corridor, or moving various spaces within the floor plan. So the final design emerged through an iterative simulation process, which not only allowed us to apply the experimental method to architectural design, but also to really consider architecture beyond the passive container as a framework that can inform and improve the patterns of relations in space. Now, remember the bathhouse and the elaborate heating and plumbing system that powered a single candle? What if I told you that the story isn't true? About a year ago, I decided to write about the building, thinking that just as it had inspired me throughout my career, it could do the same for others. But as I began my research, I discovered that the candle was really a torch. There was not one, but multiple boilers, and the connection with the sewage had never really been proven. Some have even argued that Sheikh Bahai was not the architect of Sheikh Bahai Bathhouse. So the mystery was not a marvel after all. It was simply a myth. You can imagine how deeply disappointed I was. But then I thought to myself, so what that it's not true? So what that the bathhouse wasn't actually heated by a single candle or fueled by biogases? It doesn't matter as much whether it did or didn't happen, but what matters more is that at its core, these imaginative solutions are possible. It is possible to have objects or furniture that can move and interact with our bodies. An office where the circulation is synchronized with the schedule and pattern of activities. Or a building where the sewage can function as fuel for heating. For me, architecture is the realm of those interactions. The disciplinary exchange of knowledge and expertise, the technical intervention of tools, software, and modes of practice, and the physical interplay of objects, bodies, and particles in space. And oftentimes, it is also the difficult conciliation of reality and imagination. Thank you.